Hi everyone, I'm so glad you're here. This is Middle School Math with Dr. K, and today we are continuing our study of angles by talking about complementary and supplementary angles. If you haven't already, I would suggest you start out with my first video called Angle Basics, and I'll drop the link here. That video talks about what an angle is, how we measure it, what the notation is, and also why it's important to talk about angles. That'll give you the foundation for all the notation I'm going to use in this video, so it's a great place to start if you're not already somewhat familiar with angles. Otherwise, we're going to dive in today to two new angle types. We are going to jump right out there with the definition of complementary and some practice examples with complementary, and then the same for supplementary before we wrap up this video today. Hopefully, I'll be able to do that all in a reasonable amount of time. So let's start with complementary angles, and we're just going to dive right into what the definition is. Complementary angles are two angles that, when you put them together, they have a sum of 90 degrees. So you'll see a couple examples in front of you now. These are two angles that are two separate angles. They're both 45 degrees. If I were to add those two angle measures together, I would see that they would equal 90. Now, you most often see them connected or adjacent, like in this picture. These angles are 60 degrees and 30 degrees respectively, and if I add them together, their measures have a sum of 90 degrees, which makes them, again, complementary. Now, these angles are how you will typically see complementary angles right here. You will typically see them as adjacent angles, and adjacent angles are angles that are touching. They share a common point. In this case, the point is H, and they share a common ray. In this case, the common ray is HI. So this is one example of some problems you might see about complementary angles. It says, find the complement of each of the following angles. What that really means is you've been given one angle in a two-angle set. The two angles put together have to have measures with a sum of 90 degrees, but we're only seeing one of those angles. They want to know what would the measure be of the other angle. Because I know that their sum has to be 90 degrees, this is actually a relatively simple problem. I can take 90 degrees and subtract the 15 degrees I've been given, and I know that the complement of angle ABC has to have a measure of 75 degrees. Likewise, in this second problem, you're given an angle with a measure of 87 degrees. And I know that complementary angles have to have measures with a sum of 90 degrees. So I can subtract the angle I have, and then I can figure out that the complement to angle XZY has to have a measure of 3 degrees. Here's another problem type you might see when working with complementary angles. Here it says, solve for the missing angle measure. Now, it's important to really know what you're working with. We have to know that we've got a right angle, or we have to know that we've got complementary angles before we can assume that it looks like it's a right angle. For example, I might see an angle that looks like a right angle, but it could be 89 degrees and not 90. To the naked eye, it's going to look very, very similar, and we won't be able to tell the difference unless we got out a protractor and actually measured it. In this example, I do in fact know that I'm working with complementary angles because I can see that I have the right angle symbol, which tells me that angle SGM is a right angle, which means that SGK and KGM must be complementary angles. Now, once I've got that, I know that they have to have a sum of 90 degrees, so I can take 90 degrees and subtract the 32 degrees that I already have, and I'll find that the missing angle measure, or the measure of angle SGK, is 58 degrees. Here we've got another problem that is very similar to the last one. I can see my right angle symbol. I can tell that I'm working with angles that have a sum of 90 degrees. Now, I wouldn't exactly call these complementary angles, even though I know they have a sum of 90 degrees, because typically we reserve that terminology for when you're working with two angles, and this time I have three. But because this one is really in line with the idea of complementary angles and angles that have a sum of 90 degrees, I wanted to show you an algebraic example. So here I have a 30-degree angle, a 3x degree angle, and an x degree angle, and I know that they have a sum of 90 degrees because I can see, again, my right angle symbol. Remember, you have to know that you're working with a right angle. You're not allowed in geometry to look at something and say, it looks like 90 degrees. No, we really need to know what we're working with. We can't really make assumptions in that way. So once I know that I'm working with a right angle, I can actually set this algebraic problem up with an equation. And I can say that I know that 30 degrees plus the 3x angle plus the 1x angle has to equal 90 degrees. Now, while this looks really complicated, it actually gives me something solvable. We've done work like this before. So I'm going to draw a line down the equal sign. I often do that so that I remember to balance the left side and the right side. That's not an obligation for you by any means, but if it helps you, it's a great strategy to pull from. Now I see that I have some like terms here. I see that I have a 3x and an x, which remember, if you see just an x, that's the same as having a 1x. Once I notice that those are like terms, I can put them together and combine them to become 4x. Now my goal is to isolate that x, so I'll need to get rid of the 30, and I'll do that by subtracting it. I subtract it because 30 minus 30 is 0, so that removes it from the left-hand side of my equation. On the right-hand side, I subtract 30 to keep my equation balanced. So whatever I do on the left, I have to do on the right. That leaves me with 90 minus 30, which is 60. Now again, I'm really trying to isolate that x, isolate that variable. It is currently being multiplied by 4, so I'll divide by 4 on both sides, and that tells me that x is equal to 15 degrees. Now in a problem like this, often when you find x, you're not actually done with the problem. In this case, I see that I have an angle that is x degrees, so I know that this angle is 15 degrees. But the problem told me to find the missing angle measures. I've only found one of them to this point. To find this other missing angle measure, I'll need to do 3 times x, or 3 times 15, which is 45 degrees. Make sure that you really tune in to the problem and what it's asking. Sometimes it asks you to solve for x, but other times it wants you to take that x and plug it back in and find missing angle measures. Now, supplementary angles are slightly different, but similar to complementary angles. It's just that they have a sum of 180 degrees instead of a sum of 90 degrees. So they make what we often call a straight angle or a linear pair. Now, this is an example where they're completely separate and they're supplementary. This, again, is an example where they are adjacent angles. Remember, that means that they share a common point, a common vertex, and a ray, but they don't overlap. They're just touching. So these are examples of supplementary angles. You most often will see it in this form, and we have a special term for those when they form a line together. We call that a linear pair. So if you hear that terminology, that's what they're talking about. They're talking about supplementary angles that form a line together. They're connected, they're adjacent. So again, this is a problem type you might see. It says find the supplement for the following angle. And what this is really saying is there exist 2 angles, but you're only given one of them. We know that together, the angle measures have to have a sum of 180 degrees. Well, if one of them is 135, I can find the other relatively quickly by subtracting 135 from 180. Once I do that, I can see that the supplement to angle JHK has an angle measure of 45 degrees. Let's do one last algebraic problem before we wrap it up for today. Here we've got a picture with a linear pair. So remember, we talked about a linear pair being a pair of angles that is along a line, and they are supplementary. They have an angle measure of 180 degrees. So this example, much like the one we did with complementary angles, is algebraic. It's got variables in it, and we need to do some solving. Now, when I see a problem like this, I know that they are supplementary, that they'll have an angle measure of 180 degrees when put together. So I can set up a problem that says my 7x angle plus my 5x angle have to have a measure of 180 degrees. In order to solve this, I see that I've got some like terms, 7x and 5x, which together equal 12x. Now I don't want 12x, I want 1x. So I'll need to divide by 12. And again, I'll do that on both sides. If it helps you to balance the equation and see the left side and the right side, feel free to draw that line down the equal sign. Now 12 divided by 12 on the left-hand side leaves me with x, or 1x. And 180 divided by 12 gives me 15. So I've found the value of x, but if I look back at the problem, what I'm really looking for is the value of the missing angle measures. So I'll need to take that x and use it. To find this angle measure, I'll need to do 5 times x, or in this case 5 times 15, which gives me 75 degrees. To find this other angle measure, I'll need to do 7 times x, or in this case, 7 times 15, which gives me a value of 105 degrees. And we can check ourselves on this problem because we know that we've got a linear pair. We know that we've got supplementary angles. So if I add those two angle measures together, I should get a value of 180. And in this case, I do, which tells me that we've done this problem correctly. The solutions to this problem are the missing angle measures. So I have found that they are 75 and 105 degrees. So we have very quickly buzzed through a lot of information and some hard algebraic questions, but here are some big takeaways that you need to know. Adjacent angles are angles that share a ray and actually a vertex, and they don't overlap. So you'll see adjacent angles a lot. We also referred to, and I didn't list it here, linear pairs. Remember that linear pairs are pairs of angles that form a line, so they often look something like that. Now, complementary angles have a sum of 90 degrees and supplementary angles have a sum of 180 degrees. And one of the tricky parts to learning this content is keeping those two separate and remembering which one is which. So that might be something that you refer back to. You write down in your notebook and you practice. You have someone ask you which one is complementary, which one is supplementary, because it can be kind of tricky to keep the two apart. But I hope that gives you a general understanding of complementary and supplementary angles, the differences between them, how to solve some interesting algebraic questions. I'll have a follow-up video on some new types of angles. Those angles will be vertical angles, and I would love for you to join me there. Otherwise, I'll see you next time. Have a great day.